Great. Well, welcome everybody. I know I think it's probably late afternoon in Romania. It's the start of the workday where I live in the center of the United States. But I'm thrilled to be here virtually. And hopefully, this should be an interesting talk, especially given what Holly was just talking about in the previous session, because I'm going to talk about an array of different architectural concepts dealing with distributed or service-based software. This is an architecture talk, so there won't be any code, just heads up. Sometimes I do try to do demos in this sort of a talk, but it's really difficult because we're talking about big concepts and the ways that software is organized. And at the end of the day, almost all software is represented to you and I and our users through some sort of a human user interface. And this has nothing to do with the look or feel of the user interface. It's what's all behind it, right? So I'm going to start by talking through, and maybe this is a historical perspective, but I don't think so. One of the things that I've learned in my career is that technologies last far, far longer than any of us think they will. And also architectures and ways of thinking about building software also last for a very, very long time. And in fact, and Holly mentioned this in our transition, it's kind of a pendulum. It's we go back and forth between thin client and a rich, thick client, and between distributed systems and not distributed systems, and we go back and forth. And so right now, what we're seeing in the industry is a backlash against microservices and that whole concept, because a lot of people have tried it for quite a while. They've either done it wrong and it's failing, or they've done it correctly and they've discovered that it's very complex and quite expensive. And there is no, I have yet to encounter an organization where the microservices was done correctly and the developers are happy. That happens. But then upper management is like, why is this taking so long, and why is it so fragile? Or there's a whole host of costs that they didn't anticipate because they were convinced that it was a miracle cure, a silver bullet. And of course, nothing really is. So the risk, I think, that we face today is that a lot of people are saying, oh, no, don't do microservices. You should do a monolith. Monoliths were good. And I don't totally disagree with that, but an unorganized monolith, which is really where I started my career, you just kind of write your code as a whole bunch of functions or methods. When I started, they were called functions because it was Fortran. It is just kind of this big unorganized ball of mud is the anti-pattern, right? And it's very difficult to maintain. It's very fragile. It's hard to scale. Holly mentioned the various ilities in our transition talk, and it's very difficult to get reliability, scalability, or anything else out of an unorganized monolith. So I surely hope we don't go back to that, right? Now there is a thing that a lot of people call a modular monolith. If you were in the industry in the mid-1990s, this was also called N-tier. And where the idea was you'd say, we can break our software logically into a presentation layer, a business layer, and a data layer. Now in the 90s, and Microsoft actually at the time coined this as Windows DNA, they didn't talk about it like layers. They used the word tier. So they said, oh, there's a presentation tier that runs on your client PC. And there's a business logic tier that runs, or an app server tier that runs on a server, and there's a data tier that runs on a different server. And so they were always talking about 3 physical devices with network boundaries between all 3. And that was bad, because not every piece of software needs to have 3 tiers or even 2 tiers. I, in my career, have worked multiple times on point of sale systems that essentially run cash registers. And in that case, you want everything should run on one device that's physically there at the cash register. And that might seem counterintuitive. You might say, no. At least the database should be running in a central location. But a lot of bigger stores don't want that, because if the power goes out and there's some sort of catastrophic power or network failure in the store, they still want the cash registers to continue to work. Because as their employees are hopefully shepherding all of the customers out safely, they want the customers to continue to make purchases on the way out, even if the only thing in the store is emergency lighting. And so that means that the cash register has to be completely standalone. It has to have its own data, it has to have its own business logic, and it has to have its own presentation. So I like this architecture, but I think I've always thought it was too simplistic, partially because people called it N tier when they should have called it N layer, or 3 tier when they should have called it 3 layer. And it's too simplistic. And so for, I think, since the probably 1996 or something, I've been talking about applications in the context of a 5-layer model, where there is an interface, not a presentation per se, but an interface. And I use the word interface on purpose, because it might be a web browser interface for a human, or it might be a graphic interface on an iPhone, or a graphic interface on Android or Windows, all of which might use different technologies. But it also might be an interface for another program. So it might be XML, or it might be JSON, or it might be binary, BSON. There's all sorts of formats that this interface might take, not just for humans, but sometimes for other applications or machines. Now, behind the interface is a layer of software called interface control. And really, these two combine, if you think about it, to that old concept of a presentation layer. But there's a real difference between the interface and interface control, especially if you're using any of the M-style design patterns like MVP, MVC, MVVM, and so forth. All of them separate the view, the interface, from any sort of control logic that might be running in a controller or a presenter or a view model or whatever. And this is good, right? Separation and clarity helps us create more maintainable software. Now, behind that yet is some sort of business logic. So that is the green box in this diagram. And your business logic could be implemented in many different ways. It might be in a rules engine, it might be in a function library, it might be in a set of domain objects using an object-oriented design philosophy. There's many ways that you can implement business logic. The real important thing here, and this is what's so hard, is that the business logic should be separate from the interface control or the interface. And so, and a lot of people know this. In fact, I think most of us, understand this, but it's so hard to do it in real life, because you're writing a website and you've got a controller, and it's so easy to just write a little bit of business logic, right? I'll validate that field, or I'll calculate that value, and I'll just write it in the controller, because I've already got the controller, it's right there. And of course, at that point, you've broken your architecture. It's really no different from if you're a Windows developer and you're using WPF or Windows Forms or something, and you say, oh, well, I could go to all of the work to create an official business logic layer, but I can just put my business logic, like I can validate this field as the user tabs off the field, or I can do these calculations when the user clicks this button. And so you end up writing all of your, or at least a lot of your logic in button click events, or that sort of thing. And again, you've broken your architecture. And if you stay in the industry long enough, you see the cost of this, because every 10 or 15 years, every enterprise app gets rewritten from scratch. And the reason that happens is not that the business changed, right? It's, I spent many years working in biomedical manufacturing, and I still have a friend that works in the same company 30 years later. And the company still does the same thing they did 30 years ago, right? Their business has not changed. Their software has changed radically. And what I think is kind of sad, though, is that every time that the presentation technology changes from green screen terminals to Windows, and from Windows to web, and from websites to web apps, and from web apps to mobile, and from mobile maybe into virtual reality, who knows? Just because the presentation layer, that interface and interface control layer, just because those change, you have to rewrite everything in the application. And that's ridiculous, because the business did not change. But the reason that we end up stuck in that cycle is because we allow business logic to leak into, to be implemented as part of our interface layers. And so it becomes impossible. And many of you may have or have helped to get away from Windows Forms or WPF apps, where most of the business logic is written in lost focus events or button click events. It's impossible. You can't separate out the business logic, and because it was done wrong in the first place. All right, so that was my rant, sorry. The next layer down is a data access layer. And this is important for the same reason as interface control, because over time, our business logic changes usually quite slowly, over a period of 10 or 15 years. It doesn't change usually that much. But our data access technology almost certainly changes. Just looking at either Microsoft or Java, either one, over the years, they keep coming up with new frameworks and new, better technologies to talk to SQL databases. And you don't want to let yourself fall behind, so you're constantly rewriting your data access layer from RDO to ADO to ADO.NET to ODBC to Entity Framework 1, and now we're at essentially Entity Framework 7, I suppose, right? Entity Framework Core version 2. But you're constantly rewriting that code, and for no real value other than to keep up. And again, that shouldn't impact your business logic. So it's important to keep these separated. And of course, ultimately, you store the data somewhere in a SQL database, or maybe in a NoSQL database. It doesn't, or an Excel file, it doesn't really matter, but you store it somewhere. Now, these layers can be deployed physically all onto one computer. Again, like my point of sale cash register example, or they might be deployed in multiple different machines. And so one of the most common approaches was to say, well, we'll deploy most of the application to the client PC, and then we'll put the data access layer on an app server, and then we'll have our database, the data storage, as a separate server. And this was the classic, what that was called fat client or thick client or rich client, three-tier architecture that really was pioneered more or less in 1996, as a lot of technologies like Com Plus or Microsoft Transaction Server at the time, I suppose. But also Enterprise Java Beans and Power Builder had an app server. This architecture was supported by all of the big vendors starting in 1996 through today. This is still a really good architecture if in fact you have a smart client, like a PC or a phone. And what we'll see is even a lot of web apps kind of work this way, although with slight variations. The thing is that right about the time that we were, as an industry, getting really good at implementing those three-tier client-server applications, it was becoming repeatable and productive, and you could walk into any problem space and just go, okay, I see how to solve this problem. The pendulum swung from a smart client model back essentially to a mainframe terminal, a green screen, except this time the green screen terminal was a browser. So it wasn't green, it had color and graphics. Yay! But it was the same idea where the terminal, your end device, was as dumb as could be, and all of the real processing ran on some central server, kind of like a mainframe, except in this case we call them web servers, and we put all of the interface control, business logic, and data access on that server, and then usually the database at that time was still separate, right? And I remember, this was probably 1997, 98, 99, when this became really a popular architecture. And I remember laughing a lot at the time, because it was basically people were re-implementing all the things that mainframes or mini computers did really, really well in the early 90s. And here we are in the late 90s reinventing the same wheel. And maybe it's better, maybe it's worse. I mean, that could be an interesting conversation. But the point is, that idea that we go in these cycles is so true. More recently, in the last probably 10 years, this idea of creating a web app has become a pretty big deal, right? Using React or Angular or all sorts of other JavaScript frameworks and now TypeScript frameworks to create an app that runs on my client device in my browser and still probably runs a lot of the business logic on a server. Excuse me. And the data access runs on a server as well. So this is pretty common, but I only had so much room on my graphic, right? I mean, the reality is that if I go back here to this picture, I see a lot of React and Angular applications being written using this architecture too, where almost everything runs in the browser. And the only thing really running on the application server is a set of services that provide access to the database. Through, basically I make JSON calls, and I get or send or receive JSON, and it gets put into the database. And I think that's great, right? Like I said, this is a really good architecture. And it's time tested, right? We all figured this thing out in the mid to late 1990s. It makes all the sense in the world that it would apply today in a web app world. Because if you really are writing a smart client web app using Angular or whatever, it's not all that much different from writing a smart client web app using Visual Basic or Power Builder back, at that point in time. And I know some people might be saying, "Oh man, well now Rocky's, being mean by comparing our shiny new things to old things." That's not my intent, right? My intent is to say that our industry, moves, like most industries, moves pretty slowly, and we rehash, we retry the same ideas over and over, and each time is a little better. So it's not like we're staying in place, but it's like, we try an idea, and then somebody wakes up one day and looks back 15 or 20 years and goes, actually, those people were pretty smart. If we took those ideas and used them today, and this is what I think is happening here. Now, I'm not going to dwell on this over much, but what I've talked about for I guess almost 25 years now is this architecture that is based around CSLA, which is the open source framework that we were talking about earlier. And the idea here is to try and get the best of both worlds, where on your client device, in your browser or on your phone or whatever, you run the interface control, and some of your business logic. Because some business logic, especially validation of values or authorization of whether a user can or can't edit a value, or can or can't see a value, if those run on the same device that the user is holding in their hand, that gives the user a rich interactive experience, which is awesome, right? But we all know that there is some business logic that really has to run on a server, maybe because it's interacting with millions of rows of data in a database, maybe because it needs specialized hardware, maybe because the algorithm is proprietary and we don't want to deploy it to somebody's browser because they might steal my algorithm. And so CSLA is designed with the idea, CSLA is all about the green box, all about the business logic. And it's all about the idea that you should be able to have business logic that runs on the client device, business logic that runs on the server, or business logic that could run in either location. So all that is prologue, right? I'm just going to briefly talk about what I call, and a lot of people I think call, cloud native. And I came in again right at the end of Holly's talk, in the last talk, and she mentioned Netflix, and a lot of this cloud native stuff is documented out of a lot of Netflix experience, and that's all true. And we owe them, I think, whether you like their programming or not, we owe Netflix and a lot of folks in that space gratitude. And thanks, because they took the time to document and talk about how they solved some very complex problems. Most of us don't have that level of problem. And I think that's the thing I want to start with here, is that when you start getting into the more complicated distributed system architectures like microservices, your first question ought to be, do I in fact have the problems that microservices are supposed to solve, right? Am I in fact super scaling to tens of thousands or millions of users that run at the same time? Most of us don't, right? In my experience, even most enterprise apps are only used, by maybe 50 people at a time or 100 people. And yes, I know there are apps that get used by a couple thousand people at a time, but most of us don't end up working on software that's being used by 100 or 500,000 people literally at the same time. And if you do, then you need to look at the complex solutions because you have a complex problem. Makes sense, right? The thing when we start talking about service-based systems is that terminology matters a lot. And the reason being that I often have conversations with people where they're saying, "Hey, I want to create a microservice-based application." Well, that actually makes no sense. Those words don't go together, and the reason is that each service is an application. The whole point, in fact, is that each service can be deployed independent of anything else. right? So it's a complete standalone unit of functionality, which is an app, right? Every service is an application. And so if I create something that is composed of lots of services, I am creating something that is composed of lots of applications. And so it gets really hard to talk about if I say, well, I'm creating an application that is composed of applications. And then you say, well, what's in each of those applications? Well, every one of those applications is also composed of applications. It's applications all the way down. You can't even have an intelligent conversation. And so the terminology I tend to use is I say, well, we're creating a service-oriented system, right? And that system is composed of many different applications or services. And some of these services are true services, like microservices, right? They run in the back end. They have an interface that's probably JSON or XML, something like that. We also have what you might call edge applications. And these are often applications that have some sort of actual human interface, a user interface, whether it's a browser or a mobile app or something like that. But edge apps tend to run on the edge of my overall system, and they interact with humans usually. And so hopefully that makes the conversation possible, right? Because now, we're using some words that hopefully make more sense. Applications ideally communicate via messages, and a lot of people say, no, I do everything through HTTP calls, and I use RESTful protocols, and that's fine, except that the document, right? REST is all about documents. Each document that you're sending or receiving through your REST call, that document is a message. That's the mindset you should take. Is that we're sending and receiving messages. Now, if you're trying to scale and get all of those ilities, like if you want the most efficient way to get scalability and fault tolerance and reliability and so forth, is to use asynchronous messaging, which means that you don't use HTTP, and instead you use some sort of queuing mechanism. And I'll get into that in a little bit. Before I get into that, though, I want to call out why, and I mentioned this at least 2 or 3 times so far, that microservices are being service-based in this model isn't easy, and it's kind of expensive. And the reason being that most of us think about creating an application, or we sit down with our user, the user has a problem, we come up with a design and a plan to solve that user's problem, and we don't stop to think that we're going to actually create multiple apps, completely standalone units of functionality that work together to solve that problem, right? And even if we do, even if as an architect I think that through, during the months of implementation of a project, the development teams, right, all of my Scrum teams or pods or whatever, however I set this stuff up, are they going to adhere? Are they going to remember every day that this chunk of functionality goes into this app and doesn't go into this other app? Right, and it's the same kind of a problem as keeping all of the business logic out of the presentation or interface layers. Right? It's the same kind of problem, only it's way harder, right? Because I have to think, well, this business rule, I can't implement it. I don't own this business rule. This business rule has to be implemented in this other application, and I have to make a service call to find out the answer, right? And I think, well, but it's getting close to the end of my work day. It's a Friday. I got to be home pretty. I'm under a deadline. The sprint is ending, it's a Friday, I got to pick up my child at childcare and take them, to play football. And so, well, I should do it this way, but I'll just write this line of code in my application where it does not belong. But now I'm done, right? Yay, I win. And this happens every day, which is why microservice architectures are so hard to implement in reality, because all of us, you and me, we're under deadlines, and we have real lives, and we don't always stop to think about the consequences that I wrote this like 1, 2, 3, 5 lines of code in my application where it does not belong. Everything's going to work great for like 6 months, and somebody in the future is going to hate me forever because I made their life miserable. All right. Again, that was a rant, sorry. Moving on. So understand that microservices is an enterprise architecture, right? And this is important because, again, a microservice is an application. It's a standalone unit of functionality that's deployed independent of anything else. And if that's not the case, then you are not doing microservices, right? But when we talk about microservices, what we're really doing is assuming everybody is already building standalone units of functionality that deploy individually. And then we start talking about how do we connect those or compose them to create a solution or a system. That is an enterprise architecture question. It's also important for each service to have a good architecture, right? Because each service is its own application. Well, we don't want to implement services like unorganized monoliths, and you can, and a lot of people do, and that's horrible, right? It's like, yay, we're back in the 1980s when doing crappy Fortran. DevOps, you cannot do microservices if you don't have good DevOps practices. And I say this with some level of confidence because if you think about what we're talking about, we're saying we're going to create a business solution for users where probably dozens or maybe hundreds of applications are going to be talking to each other, right? Our services are going to be talking to each other through messages. And we need to be able to deploy and manage and monitor and troubleshoot hundreds of running applications all at the same time. And how are you going to do that by hand? It's not realistic. And so you have to have a good, and keep in mind when I say DevOps pipeline, I run all the way through. I mean everything from requirements gathering and design into development, into unit testing, into automation testing, into release management, into security scanning, into runtime operations, a single pane of glass, so that everybody can see what's going on, both operators, help desk, and also troubleshooting from a developer perspective. So all of that is required. That's a base requirement. And most organizations don't have that. Even if they've got a good DevOps pipeline, they probably don't actually have a comprehensive single pane of glass to do all of their operational real-time monitoring, plus being able to look back historically at performance and crash statistics and so forth. All of that has to be in place before you can really do microservices. And of course, I just mentioned automated testing. But again, if my solution to my end user is composed of 150 or 1,000 or 2,000 apps, I can't hope to manually test them. They're going to have to be tested in some sort of automated manner, using Selenium and tools like that. So I talked about this disorganized monolithic app idea, and hopefully we never go back here, right? But I say that, but we already are, right? I keep running into applications that are essentially written like this, and I'm sure you do too, and maybe some of you are involved in projects where there is no reliable or repeatable following of design patterns and separation of concerns. I often run into, especially executives, not so much actual practitioners, but just, business decision maker people that say, oh, I was golfing with somebody, or I read an article in a magazine, we need to go to service-based, so we need to go to microservices. So what I think we're going to do is we're going to take all of those methods or functions, and we're just going to make each one of them into a service, which is just a disaster, right? It's the same disaster. I mean, I'm going back and forth between my two pictures. It's the same unmaintainable blob. It's just that in the service-based system, every one of those lines that connects those services is a network jump. So it's way worse, right? This monolithic app probably has performance and maintainability issues. And now what we're going to do is every one of those lines between services went from being an in-process call that took nanoseconds and became a call where we packaged up a message, put it, serialized it, sent it over the network, deserialized it, unpackaged it, and then the service does some work. So basically, we've slowed the entire thing down probably around 1,000 times, right? This call takes nanoseconds. This call takes milliseconds, right? So at best case, it's hundreds of times slower, but it's probably roughly 1,000 times slower. That's typical. So it's horrible, right? I mean, it's just that's that naive, oh, we're just going to wave the magic microservices wand. Just makes life infinitely worse, not infinitely better. What really needs to happen is we need to think this through and say, well, each one of those methods and functions that we have in our current implementation, they're not all eligible to be a service. If I'm going to switch from a nanosecond call to something that's 1,000 times slower, my service had better do enough work that it was worth all the overhead to get over the network to that service. And so, and this is why personally I really dislike the term microservice, because a service has to be big enough to be worth all the overhead to make the service call. So if my service runs, if it's so micro that it, if I write a service that just does some math, that's horrible, right? I'm going to spend, probably, 30 or 50 milliseconds getting to and from that service so that it can run a calculation that took a nanosecond. That's like going to the grocery store, because I want to make some food. So I go to the grocery store and I buy a can of beans, and then I come home, and then I go to the grocery store and I buy some bread and I come home, and then I go to the grocery store and I buy some milk and I go home, right? Nobody would do that. That's really dumb. And yet that's what a lot of people think with microservices, right? No, the microservice is the store. I go to the store and in one thing, I get the beans, I get the milk, I get the bread, I get the cheese, right? And then I come home. And so I made one trip, one expensive trip by bus or car or whatever. And I did a whole bunch of work and I got the result. And that's how a microservice should work. And so it requires, well, in my view, you should use domain-driven design concepts in order to break your problem apart and say, here's how I design my services. That's a whole different talk. So what does a service look like? And this, I throw this in here just because so often, we're talking about this and thinking in terms of how do I implement these things in code. And the idea that a service endpoint takes multiple discrete arguments and returns like an int and a double, and it returns an int, that's absolutely wrong. That's what you're creating there is an API that should be running, packaged up as a DLL, and it should be running in process, right? What's okay, kind of, is the idea that I'm going to send a request, a message. The service is going to do some work, and then synchronously, it's going to give me a response. So this is essentially REST, right? An HTTP model. It's not great, but it can work, especially if you're running all of your services are running in something like Kubernetes, where you've got some level of self-healing and fault tolerance that's built into the platform. But if you're not running in a fabric that is self-healing, this is really unreliable, hard and expensive to scale, and should be avoided. So the option that you should choose, if you're trying to solve these big problems, right, is asynchronous messaging, where I say, hey, I'm going to send you a request. It's a one-way thing. It's probably going to go through a queue. Your service is going to do some work, and then if I need a response, you're going to send me a message back, again through a queue. And so we get complete asynchronous decoupling, which makes it so easy, super easy, and cost effective to create geo-redundancy, to create scalability, fault tolerance, and so forth. So again, I mentioned that we should be thankful to Netflix, for example, and others, for creating a set of design patterns, actually I shouldn't say it that way, for documenting a set of design patterns that we all can use, such as these 12 factors, which if you haven't gone to 12factor.net, you really should go internalize these. These are all, following these lead you to success. As opposed to the 8 fallacies, which this is very old, and you can find these on Wikipedia, making these assumptions, any of these, will almost certainly make you fail in your efforts. The one that so many people is the reliable network. It's like, oh yeah, I don't have to really worry about the network going down. Oh yes, you do, even in your own data center. So if you're not using a retry policy with short circuiting, so in .NET, for example, use the open source Poly framework, something like that. Or if you're in, Spring Boot has got a lot of this stuff built in within that world. So these are all real problems. And if you assume any of these is safe, again, you're setting yourself up for failure. The great thing, and a lot of people, I've harped on this message idea, right, that everything should be messages. And I just want to touch on this briefly, and that is that it sounds scary because most of us were trained in university and in real life. We've been trained to do synchronous method calls and synchronous HTTP calls. But queued messaging is really well understood. I mean, this is a model that was developed and I don't know if I want to say perfected, but really, really well designed and documented in the mainframe days from before probably any of us were involved, right? This is old. And this book is not, though. This book is, I suppose it's from the 90s, though. But Gregor and Bobby created this fantastic book that documented the design patterns around messaging. And I guess what I'm getting at is don't be afraid of messaging. Messaging is your friend. Messaging might seem scary to start with, but in fact, if you use something like RabbitMQ with AMQP, or if you use MQTT protocols, there are frameworks, tools, and design patterns that will help you be successful. So to end this, I'm going to kind of come back around to my original diagram style and say, okay, if we're going through this world where we're all service-based, right, we're going to create services. A service is an application. Its interface is message-based, right? It might be JSON or binary, but whatever. But the interface itself is messages that are coming and going. It still has interface control. Something has to read the messages off the queue or send messages onto the queue. It still has business logic, because if I'm creating a service that doesn't actually do anything, then what the heck am I creating the service for? And services typically persist their own data. When I create a service-based system, I'm probably going to have some sort of gateway for external users, and that might be HTTP based, right? In other words, my browsers are going to talk HTTP no matter what I do. But so the browser is going to talk to my gateway, then it's going to send messages through my messaging pipeline to services. And services are going to do interesting things and send results back out to the gateway. Now, what's really fun about this is that all of the original architectures that I talked about, well, all the good ones, still apply. It's just that instead of persisting their own data, right, I might be creating a web app or a mobile app or a Windows app or an old style, server-side web app. All of them, instead of persisting data, can talk to my system of services by talking through that gateway. Right? This is pretty awesome stuff. Now, in real life, what happens is a little more complex because usually my website will have its own data storage because it is an app, right? And some of what it does, it's going to do all by itself with its own local database. And some of what it does is going to happen by talking to my system of services through queued messaging. And so it's a little more complex, but the architecture remains intact. And so really where I want to end this is that if you have the problems that services solve, which is that you need to have independently deployed, independently versioned applications that are used together to create a complex system, then you should absolutely look at microservices and service-based architectures. But you should also keep in mind that these, I don't know, quote unquote legacy architectures like N-tier and, and so forth remain incredibly valuable. And you can use the best of both as a possible solution. And if I think back an hour ago, Holly and I were talking just a little bit about how hard this is, because like she said, everybody wants either N-tier or microservices because we want something that's simple. We want one architecture to rule them all. But in real life, that's not the way it works. In real life, you're often better off creating part of your application using a nice, well-tested N-tier model, and then where you need the features of services, create a service-based system so that the N-tier architecture can use your services as appropriate. Right? That kind of is in a nutshell what I'm trying to drive home here. So with that, I want to thank you all very much for your time today.
And thank you very much, Rocky.
Can you hear the community? Well, I'm really looking forward to that moment. It's well, something that we're all missing. Very much enjoyed.
Yeah, I really love the presentation as well, and I love the step back in time and going through the traditional ways of designing the architecture and to the modern ones and how they combine. And yeah, and it's about combining and see what patterns fits. But I think in practice the challenge is because you need to decide on something when you know least about the project. So when you're going to start. So then probably the challenge is not to, I think you also said it like that, not to shoot yourself in the foot and do something that you can improve in time or evolve.
Yeah, I agree. And I think the real important thing is to maintain separation of concerns. Even in a small project from the very beginning, if you keep your business logic separate from your interface and separate from your data access, if that's all you do, that gives you the flexibility later on to make those changes, and not for free, but at least it's possible to make those changes.
And you're also mentioning technology upgrades, and I think this is something that we like as developers, to work on the latest stack. But what we see when we talk to our customers, for instance, is that you see that something's legacy and it's not upgraded. It's 3 or more versions back, and you already have a signal because we want to do this. But then you find, when you look into the architecture and the code, you see that the problem is that things are not decoupled. So then it's difficult to migrate and upgrade. So you need to start from ground zero.
Yes, right.
Would have loved to have more time to continue the conversation, but I really hope that we'll have another chance.